Metrology is responsible for some of the largest leaps in the betterment of our species. One way this is true is through the impact on the development and manufacture of semiconductors. Semiconductors have had a profound impact on almost every aspect of our daily lives. Cars are safer because of semiconductors. Food is more plentiful because of semiconductors. People are more informed because of semiconductors. This report intends to demonstrate how semiconductors have influenced our lives and how metrology has done the same by improving semiconductors. What are semiconductors? Semiconductors are electronic components typically made from silicon that have had impurities introduced to affect the conductivity of the material. They serve as the basis for integrated circuits, which almost all modern electronics make use of. The first versions of what we would call a computer today were invented during the mid-20th century. These computers were enormous, occupying entire rooms and weighing several tons. They were difficult to program and consumed several kilowatts of power with each use. Around the same time, the work of Brattain, Bardeen, and Shockley produced the first transistors. Transistors are small electronic components that use semiconductors and function like switches, directing the flow of current through a circuit. Combinations of these switches create logic gates and memory programs, which serve as the basis for modern computing. With the invention of the transistor, computers began to shrink. What once occupied a 30 by 50 foot room became small enough to fit in your pocket, while also becoming many times more powerful. How can this be? The answer lies with metrology's impact on the manufacturing process of semiconductors. Semiconductors are made through a complicated process involving between 400 and 600 steps. In brief, semiconductor wafers are turned into chips using a technique called photolithography. First, the entire silicon wafer is coated in a substance called photoresist. This substance hardens when exposed to light. By shining the negative of the desired chip pattern, the photoresist creates a mask that will prevent the areas beneath from being etched in the next step. To fit more components onto a chip of a given size, the components must be very small. In turn, the pattern used to create the chip must have very small features. To achieve these small features, the light used to create the pattern must have a very small wavelength. Typically, ultraviolet light is used to create these small features. Ultraviolet light has a wavelength as small as 100 nanometers. However, by vaporizing microscopic molten tin droplets moving at 157 miles per hour, 50,000 times per second, extreme ultraviolet light, usually shortened to EUV, can be generated. EUV has a wavelength of 13.5 nanometers. Advanced metrology techniques are needed to make sure that 1. The tin droplets are the right size, 2. Hit those droplets as they move so fast, and 3. Repeat this process quickly and consistently enough to generate enough light to manufacture chips. Another area metrology makes an impact in the manufacturing process of semiconductors is in inspection. Since many chips are made from a single silicon wafer, it is very important that overlaps are avoided, as that would ruin an entire batch. Additionally, it is very important to find any defects on the semiconducting wafer before manufacturing chips, since defects prevent the photoresist from adhering properly and may ruin a batch.